Now let's talk about the history of blockchain. We did the history of the internet, now blockchain. Enter crypto and cryptography. Remember when we said earlier that one of the things that was missing in Web 2.0 was our unique digital identity as an internet protocol? Currently, our digital identities are controlled by others in centralized fashion, or Facebook, right? And because of that, privacy breaches and hacking became commonplace. A recent example would be the 2016 US presidential scandal, where Cambridge Analytica, a British company, developed detailed psychological profiles of every American voter. This information was then given to the campaigns so they could tailor their pitches from person to person. It's actually why Facebook got fined for handing over that private data. Now there's a way to protect our personal data, to claim it as our personal asset. This meaningful way of protecting data is known as encryption. And not just encrypting the data, but also encrypting the transfer of the data. The root of encryption goes back to the word crypto. Crypto comes from the ancient Greek word kryptos, meaning hidden or secret. The earliest known use of cryptography is found in non-standard hieroglyphics carved into the walls of tombs in ancient Egypt around 1900 BC. Others point to Julius Caesar, who was thought to have used a form of encryption around 100 BC to convey secret messages to his army generals. Be that as it may, with the invention of computers and coding, cryptography has enabled humans to transfer information in a more secure fashion. Blockchain is the technology enabled by cryptography that will allow for this protection. Accomplishing this, you use decentralization, which enables the trust to conduct the peer-to-peer communications. Imagine being able to send your child $1,000 without a trace of doubt or fear that it will arrive safely and, oh yeah, instantly to them. How? Public key cryptography. It strikes at the core of the crypto industry. This is not a new concept. It's actually been around for a long time. Let's look at a simple example to see how public key cryptography actually works. Bob and Alice want to communicate directly and privately. Alice is sending a private message to Bob. In order to receive that secret message, Bob's computer comes up with a random number. Doesn't matter what the number is. It's a big, long, random number that Bob's computer came up with. That's called a private key. Bob keeps his privacy and keeps that secret. Then, through a special mathematical formula, Bob's computer takes that private key and generates a related public key. This public key can be shared on the internet, everywhere you want to go, blogs, Twitter, shopping, whatever. And it's safe for the world to see. But there's no way for anyone to take Bob's public key and trace it back to his private key. It's a one-way function only. Alice takes Bob's public key and encrypts her message. The result is gibberish, and only Bob, through his private key, can decrypt the message. This way, Alice can send an encrypted message to Bob, and only Bob can decrypt it to read it. Now, if Bob loses the private key, he can't open the message. If someone steals Bob's private key, he's kind of screwed. The same concept holds true if Bob is sending a message to Alice. This way, they can communicate securely and directly without the need of an intermediary through the use of computer algorithms. So we have some methodology to create a safe and trusted world within this current broken internet.